let's talk about APIs and about security and about API security testing. The title of this talk, Are You Sure Your APIs Are Secure? Um, and let me start by the why behind this talk. Why do we as testers, development teams, have to concern ourselves with API security testing? These are figures, numbers from 2022. I don't think they've changed much since. But in 2022, 83% of all the traffic that's being transferred on the internet is API driven. And that is a lot of data. And some of that data might be public, but there's also lots of data um, that is, well, not there for everybody to see. Um, but people want access to that data. People with malicious intent, sometimes people call those hackers, they want access to that data. They want um, to see that data, scrape that data, use that data, sell that data. And APIs are much, much easier to access compared to, for example, databases or servers or file systems or whatever. That has led to lots and lots of high profile breaches over the last couple of years. And governments, like, for example, we in the EU, I am based in the Netherlands, we have GDPR. Um, which means that we need to take care that our data is safe. And because we need to take care that the data is safe, we need to concern ourselves with the security of the APIs that expose and transfer that data. So typically I've been in testing and more specifically in automation, but this is more like a general testing talk. API security testing was typically something that is, let's leave that to the experts. That is a very specific corner of the testing world that we have the security testing specialists who will take care of that. And to some extent, that is still true, but there's also a lot that we can do ourselves without that deep security testing knowledge, without using highly specialized tools. And that's what my talk about is today. So I'll talk a little bit about API security, but most of all, I want to show you how you too can perform um, API security tests with what is a basic, some basic, just common API testing tools. I'm using Postman in this talk, but that could be Bruno, that could be Karate, that could be Rest Assured, that could be basically any common regular API testing tool. And the only other thing you need really is a healthy dose of curiosity, creativity, and common sense. The good news is that's what we have. That's what we bring to the table as testers anyway, or at least that's what I think we should bring to the table as testers anyways. So without further ado, without further talking, let's just get started. So what I've got here is my trusty Postman installation, and I've got a number of examples prepared for you. And depending on the time, I want to allow some time for Q&A. So at some point, I'll just stop talking and hand it over to Olga to see if there are any questions or anything. But let's get started first. So this is a very simple, basic endpoint running on my local machine that creates new users into a system based on a query parameter that contains the username. So if I create a new username called John, it'll create a new user with a uniquely generated ID for me. And if I create another user, Susan, it will create another user with, again, a uniquely generated user ID for me. So far, so good. Functionally, this API seems to be doing what it should be doing. However, if I, and this is a typical test for us as testers, if I leave the username blank, or if I remove it altogether, that would have the same effect. We'll see this. Bad request, and just a stack trace with, um, and we've all seen these stack traces as testers. And from now on, I want you to treat these not just as, oh, that's a problem, something's not working, but also as, oh, there's a problem, this is a security risk. Because these stack traces contain a lot of valuable information for people with malicious intent, because it tells me uh, what programming language we're using. Java here in this case could be anything else. It tells me the kinds of libraries that are used to implement the backend here, or the API provider. If I would look really closely at this text trace, it might even tell me which specific version of a specific library is being used. And that is all very useful information for people who want to exploit that kind of information, because maybe a specific version of a specific library has a known security weakness, a known security vulnerability, which can then maybe be exploited by those hackers. So anytime from now on, please, if your API or your system in general shows a stack trace to an end user or whatever, treat this, please, not just as a functional issue anymore, but also as a security risk, because this is lots of useful information about the implementation of your system that can then be abused. So, exposing that's what I call exposing sensitive implementation details. Please make sure that the people who use your application, look at your application, are interested in your application, only see what they're supposed to see, and don't expose implementation details that can then be abused potentially. All right. Next example, pretty similar to the previous one. Let's create a student here in some kind of student administration system, but this time through a JSON request body instead of using query parameters. So I create a new student, John Smith, who's in the computer science program. Awesome. All good. Works like a charm. One of the first things I'm interested in when I'm testing an API and when I'm interested in the security of this API is, how does this API handle potential injection of malicious content? So this is a quick example of a snippet of JavaScript. This is a very benign script, JavaScript, so it's a little bit annoying maybe because it shows a pop-up, an alert, but it doesn't do anything uh, really malicious. So I want to know, are these values sanitized? Is my API properly sanitizing the input? In this case, we'll see it doesn't. Sure, and this is probably not an existing major, but that's not the biggest problem. The biggest problem here is this is now a value that's stored in a database somewhere. And that could also be a value that's pulled up somewhere in a browser. And browsers, they love JavaScript, they start executing the JavaScript. And that could potentially send all kinds of interesting information that is stored in a browser to someone as a credit card data, cookies, access keys, whatever, to people who can then abuse that information. So one of the first things to check, I think, with an API is how well does it handle potentially malicious input. This is just a and that vulnerability is called injection. This is JavaScript injection, sometimes also referred to as cross-site scripting. But this is just one example. Here we have the big, what we call the big list of naughty strings, which is a super useful resource for any tester because it contains all kinds of interesting strings and values that you can use in testing your application. And one section specifically talks about, it gives you IDs for JavaScript snippets that you could use to see how does my API handle this kind of input. Also, there are SQL injection snippets. So let me very quickly pull up the relevant XKCD here with that student who entered this as their name, which caused the entire students table to be wiped from a system. And so there's a couple of examples here as well. Super, super useful resource. If you Google big list of naughty strings, you'll find it right away. And so that's all about um, sanitizing your data. How does my API handle injection? Does it allow? So it's not just important to see, well, does my API accept valid values and benign values, but also does it not allow? Does it sanitize? Does it reject potentially harmful values? And because those things can be harmful either to other users of your system or to your system itself. So again, big list of naughty strings is a very valuable resource here. Let me do a quick triple check here to see if everything's going okay. That looks all good. Just want to make sure. And I'm happy to read that Paul seems to have arrived now. So there's loads of libraries and mechanisms that help you with injection. So please, by all means, use them. But if you thought, well, oh no, nobody really falls victim to these kinds of issues. Okay, this is a couple of years ago, but somewhere around 2015, 2016, eBay had a major exposure, a major data leak, access to their system through cross-site scripting, through a little piece of JavaScript injection. Because they had a parameter somewhere in an API call that retrieved the website that enabled attackers to gain full access to eBay seller accounts, which is not a very good look for eBay, and also not something that they intended. It was not intended or scheduled upon functionality. So this is just an example of why we should test for this. And it's not super hard to test this. It is pretty straightforward. So everywhere that your API receives data, so it could be through path parameters, query parameters, form parameters, or through headers or JSON cookies or JSON request bodies or XML request bodies or whatever kind of data it accepts, see how potentially malicious data is handled. So injection is, I think, number 3 on the general OWASP security top 10. So OWASP is the Open Web Application Security Project, which is a team of people, practitioners, researchers that concern themselves with security on the internet. And since 2019, they're also maintaining a top 10 list of API-specific security vulnerabilities. And I wanted to, in the remainder of this talk, I wanted to show you some of those vulnerabilities, what they look like, how to look for them, and how to talk about them. So let's start with Probably the biggest problem in APIs. APIs exposing data that people should not have access to. So I'll show you another example here. Is I'm retrieving data. Shut up, postman. I'm retrieving data related to my account. So I'm Susie. I have an account with this bank. My account number is 543. So when I retrieve that data, I can see, oh, this is my account. It's a checking account, and my current balance $1,500, Smurfs, whatever. So that's all good. So Susie is maybe a little bit curious as a, let's see what happens if I try, if 543 is an existing account, there's a good chance that 542 is also an existing account. Um, but it's not found. So this could either mean there's genuinely no account with this account number, or it does exist. She's just not Susie's just not supposed to know that it exists. So 404 is a very reasonable um, response status code here. But if a hacker, that hacker could be Susie, could be someone else, say, well, ooh, this looks so. I probably, if 543 is an account number, let's just see what happens if I iterate over a list of potentially valid account numbers. So let me quickly select a JSON file of a CSV file that I've prepared for this with a list of potentially valid account numbers. So every from 500 through 599. Use locally. I'm going to run that. What I've also added here is a quick check that checks that the status code is 404. Now you should know that Susie only has a single account with this bank. So what I expect is 99 passes and one failure. And that failure is for account number 543 because that returns a 200 and not a 404. So if we run that test, so again, this is a very straightforward test to run. We see that, oh, there's not one failure, but there's two. And this one we expected because this is Susie's account number. But it turns out that also when we retrieved the account data for the account with number 572, we also got a 200. So let's see what happens there. If we say 572, and again, keep in mind, we are still authenticating as Susie, but now we can see data that's associated with, or the account details for an account that's associated with Andrew. And Susie has no idea who Andrew is, but she now sees, well, oh, Andrew Simpson has a savings account with a pretty high balance here. So this is an example of how you could easily test for, and how again, people with malicious intent try and find data that they're not supposed to see, not supposed to have access to, based on who they are. And that is a vulnerability that in OWASP terminology is called broken object level authorization, or BOLA. And in fact, on the most recent API security top 10 vulnerability list, it is number 1. So this is the most common API security vulnerability as of 2023. And the ability, the fact that people can see data through an API that they're not supposed to see based on who they are. So some things to look out for here is if your API uses predictable resource IDs. So in this example, that account number is super, super predictable. So we can easily create a list of potentially valid resource IDs, account IDs here, and just iterate over it. Or if there's an endpoint that gives you a list of all valid resource IDs, that's also something that can then be used as input for a test like this. And so these are all potential potential weaknesses in the security of your API related to broken object level authorization. Another problem that we saw with this specific test is that this API endpoint seemed to just accept me doing 100 requests of these time. There was no rate limiting. And so I could just do a potentially infinite amount of requests in a short amount of time. And that's another way to make it easier for hackers, people with malicious intent, to try and do at the kinds of data searches or scraping or whatever you want to call it on an API. So rate limiting, and that is restricting the number of requests a certain machine or a certain person can do to a specific API, to a specific endpoint within a specific amount of time. That is called rate limiting. And in this example, we saw an insufficient, or in this case, a total lack of rate limiting. And that in itself, that insufficient or total lack of rate limiting is another vulnerability on that OWASP API security top 10. It's called unrestricted resource consumption, and it's number 4 on the list. So this too is a vulnerability in and of itself because it just enables hackers to try out lots of different combinations and values of resource IDs or authentication details or whatever. So you probably want to restrict that if you are concerned with the security of your APIs. This is just an example of Ebola vulnerability or exposure in practice. So the U.S. Postal Service back in 2018 had a weakness that allowed anyone with an account to see user data for lots and lots, millions of other users, and that's all data that they shouldn't have access to, based on um, who they are. And so you should typically only be able to see your own data, but not the data of 60 million other users. So that's an example of broken object level authorization. Next one. And the next thing I would be interested in if I see something like this. If we can see that data, let's see if we can also modify it. So I've got another example here. So I gotta find, and I should be able to see this data. And because this is a fine, that's fine, that's issued to me. I need to pay 180 euros for exceeding the speed limit. Okay, it happens. I don't like paying fines, so let's see if we can get this out of the system without actually having to pay it. Go away. So one thing that I could probably try is, well, what happens if I try and delete it? That is not allowed. Let's see what happens if I try and override it. Also not allowed. Let's see what happens if I put an amount of 0 in this. So let's see if I can override a single property of this file. Also not allowed. Final attempt. Let's see what happens if I patch it. Oh, that is interesting. So now it doesn't return a method not allowed. It tells me, well, something happened. I accepted this input. And now when I try, let's see what happens if I try and retrieve it again. Let's see what the new state of this find now is. And it's completely gone. This is an example of the ability to perform actions on data other than just seeing it, and to modify data in those cases where you shouldn't be allowed to modify it, again, based on who you are, based on your authentication and authorization. And that is another very common API security vulnerability. And this is called broken function level authorization. That's the number 5 on the list. So I'm not going through them in chronological order or order of importance, order of occurrence or whatever. But these are um, this is how I would approach a basic, starting out with just looking at the security of an API, really. Um, Another example of a broken function level authorization would be, hmm, is there any endpoints that give me access to admin operations that I can access as a regular user? That's also more common than you would think. So there is some relation, or at least some correlation between the two vulnerabilities that we saw just now. So broken object level authorization, and the fact that we can see data that we're not supposed to see, and broken function level authorization, which is the ability to modify data that we shouldn't be able to modify. Because both of them have their root cause in broken role-based access control implementations. As somebody forgot to implement role-based access, or implemented it incorrectly. Which means it's probably a good idea, if you find out that your API exposes data that it's not supposed to expose to you, based on who you are. It's also a good idea to say, oh, what else can I do with that data? So it might be a good idea to check for broken function level authorization too. This is an example of broken function level authorization. This was a Bitcoin researcher who tried to sell Bitcoin using Ethereum coin. I don't know too much about crypto, but using a different kind of cryptocurrency that they didn't own. So, and it wasn't just a UI bug, it was actually on the order book. So this was a very big security issue with Coinbase, and they paid a pretty decent bug bounty here, $250,000. I don't know exactly which year this was. They've probably fixed it since. Hopefully they did. But this is an example of having access and doing data modifications that you're not supposed to be doing. And that's a prime example of broken function level authorization. All right, another example. Let's see. Let's order a game. Let us order a game. So I've got a game shop here, and I've got an order endpoint where I can place my orders. And let's see if I can order a copy of FIFA 24. Looks like I can. It's got a unique order ID. It's accepted. All good. And let's see if I can order 100 copies. I'm not sure what I'm going to do with 100 copies of the same game, but maybe I'm a reseller or whatever. And that's also accepted. That is fine. I think that game shop is more than happy to sell me 100 copies of FIFA 24, and they don't really care what I'm going to do with it. But let's say they've also got they've got hold of a very limited edition item. Let's say they've managed to get hold of a few copies of Gamma Attack, which is officially, or at least according to Wikipedia, the world's most rare video game. So if I want not the 1001, so because they want to keep as many of their customers happy as possible, they have a strict no more than one copy per customer policy. So if I try and order a single copy, that is absolutely fine. But if I try to order multiple copies, it's going to give me an error. So I am not going to do that because it's one item of one copy of Gamma Tag per customer only. The problem here is there's a scenario that they forgot to think about. because I cannot order multiple copies of Gamma Attack in a single order. But what I can do is just place a lot of different orders, each for a single copy of Gamma Attack. Is an example. The failure or the failure to recognize and take countermeasures against the different ways in which people can uh, get access to, use, abuse these kinds of business processes and avoid and circumvent these business rules that are implemented in a system is called unrestricted access to sensitive business flows, or UASBF, because who doesn't like an acronym? That is number 6 on the OWASP security top 10 list. So this isn't necessarily related to access to the data that's being exposed, but this is more related to, again, access to or the ability to manipulate, circumvent, work around the business rules that are exposed through the API. So how would we prevent these kinds of vulnerabilities? First of all, by having conversations before you actually build something. Um, that is true for software in general, but I think at the security or how could people abuse this this feature or this thing that we're building here? And that's true for APIs as much as it is true for every piece of software. Is identify, try and come up with all the ways in which people can abuse your software. In this case, well, what would happen if we don't order 10 copies of Gamma Attack in a single order, but place multiple copies of Gamma Attack in subsequent orders? And so identify the sensitive business flows and then take the necessary technical or organizational prevention measures. So, what could those prevention measures look like? Here's a couple of examples. Two that I want to very briefly highlight is human detection, use a CAPTCHA or a typing pattern or some other kind of biometric solution to see, well, are we dealing with humans here or are we dealing with a bot here? And another way to do that is, well, if there's only a couple of milliseconds between a user putting an item in the shopping cart and the user proceeding to the checkout, you're probably dealing with a bot here as well. And this is something that you very typically see if um, concert tickets go on sale online. And so you want to typically those ticket selling agencies like Ticketmaster and whatever, and they typically have lots of security measures built in to prevent bots from scalping all the tickets, from just buying up and then scalping and then reselling all the tickets for a much higher price because they don't want that. And these are the kinds of countermeasures that they take. And so human and non-human patterns, blocking certain IP addresses or ranges, device fingerprinting, those kinds of things. So it's good to know that we've seen some a few different kinds of vulnerabilities. We've seen some security countermeasures too, but none of these countermeasures, in and of them by themselves, guarantee a fully secure API. The only way to make your AI fully secure is to disconnect it from the internet, and that's really not the point of an API. Um, so, uh, um, but there's lots of things that you can do, but none of these individual security countermeasures. So we've seen the device fingerprint detection of non-human patterns, rate limiting, authorization, a role-based access control, an authorization scheme. None of these things is inherently foolproof and completely safe. But if you put a couple of these countermeasures, these security countermeasures in place, that might lead to the risk of someone being able to go through or um, circumvent or avoid all of them small enough to make it acceptable for you, and that's called the Swiss cheese model. Again, and none of these countermeasures individually is enough to make your API secure, but each of those countermeasures will hopefully lower the risk, and at some point, that risk will be at an acceptable level. And what is an acceptable level is, of course, heavily dependent on the context, on your data, on the amount of data, the value of that data, on your system, on, well, risk, basically. Um, one, two. Let me quickly see in the chat. Olga, how much time do I have left? Olga or Paul, can you tell me? I have a couple of minutes left, or when do you want to move to the Q&A? I cannot hear you, Paul. If you could just
How about now? Are we
how
good?
much better.
All right, there we go.
Oh.
Too many microphones. Oh, it's been a horrible morning. Yeah, we're only at 40 minutes in. We got 20 minutes until the break, so you got plenty of time, boss.
Okay, awesome. So let's do one or two more examples, and then a wrap up, and then some Q&A, and then awesome.
Sounds
Thank you
great.
very much.
Not a problem.
And by the way, it's good to see you.
Good to
Happy
see
to.
you again too.
Awesome. You can still see my screen, right, Paul? All right. So the next one is we all know these kinds of things. Password security. These password security measures. So these apply not just to front ends, to graphical user interfaces. We should test these kinds of things at the API level too. So, for example, maybe, so I've got a password change endpoint here. So, this is my old password. And maybe, oh, this is not a very good new password. So, EFGHIJ 456 exclamation mark. That sounds like a good new password. That's fine. That's all good. But this obviously does not meet the standards. It doesn't meet the minimum security requirements. So this looks pretty good until you try this and you find out that the actual requirement of having both both lowercase and uppercase letters is not a problem. So this is a, I don't know if this is a major or a minor security, but at this, my password is less secure than it's supposed to be now. Even though my graphical user interface wouldn't, this is, you probably want to verify these kinds of things at the API level too, because this could introduce potentially less secure, insecure kinds of passwords. This is not the biggest problem here, though, because I see a V2 here, and that triggers me. Maybe V1 is also still alive. And I don't know about V1, but let's see what V1. And V1 tends to just accept everything as a password. If I want to leave my password empty, it'll just accept that. So this is two vulnerabilities in one. So one of them, broken authentication. Again, this is related to, so we said our password needed both uppercase and lowercase characters. Turns out it doesn't. And this is just one of the many different shapes and forms that the broken authentication vulnerability takes. So it is every so um, broken authentication could also mean, oh, my token never expires, for example. So anything that is, well, literally broken around authentication is an occurrence of the broken authentication vulnerability. So in this case, this example, that's a relatively minor issue. The biggest problem here is this one: improper inventory management. It happens less often, and it's still in the top 10, but it's only at number 9. Um, but um, the bigger the company is, typically, the worse they are, the worse they score on keeping track, keeping inventory of everything that they've deployed into production. And in this case, they successfully deployed a more secure version 2 of the specific endpoint, but they forgot to um, deinstall or to remove version 1 of that same endpoint. And that is still available with all kinds of interesting security holes. And it could be a V1, it could be a beta version, it could be, I don't know, whatever. Um, but lots of companies are pretty weak at keeping stock of what is and what is not deployed into production. And they have much more available and deployed into production than they actually think they do. And that is all falls under the improper inventory management vulnerability. So this is probably and that's probably a good thing to ask next time you talk about APIs and deployments. How do we know? Are we really sure that when we deploy a new version or a new version of an endpoint, that the previous one is no longer available? That we really solve the problem by releasing the new version and removing the old one. And so, especially when you see prod or V2 or so in an endpoint in an API, it is, or live or whatever, it is probably a good idea. That probably means there's other versions too. And maybe those are in production as well. And there's a reason they were version 1 or beta or whatever, because probably, maybe there's a security vulnerability there that people can then exploit. So that is improper inventory management, or rather, I hopefully proper inventory management, but the failing to do so, improper inventory management. So that is a lot of different security issues that we talked about. There's a couple that we missed. So these are the ones that we covered. So broken object level authorization, and the fact that we can see data that we should not be able to see. Broken authentication, and in our case, accepting weaker passwords. Unrestricted resource consumption, the lack of rate limiting. Broken function level authorization, and the fact that we can modify data that we shouldn't be allowed to modify. Unrestricted access to sensitive business flows, where we could just place multiple orders of a game that was one game or one copy per customer only. And improper inventory management, the fact that people forgot to take older, more vulnerable, less secure versions of APIs or systems down when they deployed a new version. There's a couple that we missed. It's called a top 10 and not a top 6. So number 3 is broken object property level authorization, which is very, very similar to the number 1. It's just that a broken object level authorization talks about resources as a whole, so accounts. In our example, broken object property level authorization is, well, can I see properties of a resource? So individual fields or combinations of fields that I shouldn't be allowed to see. I do when I authenticate as a regular user. I shouldn't be able to see data associated with the resource that is supposed to be viewed by admins only, for example. That is broken object property level authorization. Again, very similar to number one, just at a slightly lower level of granularity. Number seven is server side request forgery. That is the ability to get access to or modify or wreak havoc on property or on provider on servers through URL properties. In, for example, in a request, if I've got a request body where I'm asked to upload a picture through URL, and just by providing the URL, I could put all kinds of funny URLs in there. I could also put um, local host reference in there to see how the server responds to that, because that might give me all kinds of interesting implementation details about that server. That is called server-side request forgery. And number 8 is a bit of an umbrella vulnerability. So all kinds of things that are misconfigured around security. And the last one is unsafe consumption of APIs. So number 1 through 9 are all vulnerabilities on the provider side, on the server side. Number 10 is it's a vulnerability on the consumer side, on the system that consumes an API. Do they actually verify the data that is returned by the API? Because that data, those values could be potentially harmful too. And maybe an API returns a malicious piece of JavaScript or um, a SQL statement or a partial SQL statement. If you don't, as a consumer, you don't verify that and you just process it on your way, you could be just as vulnerable as the provider. And those kinds of vulnerabilities are what OWASP calls unsafe consumption of APIs. I'm going to skip that one. So wrapping up, where to from here? I hope that this talk and these examples that I gave you have given you some ideas on how to get started with API security testing yourself. And hopefully, they showed you again what I said at the beginning of this talk, that you don't necessarily need super specific API security testing tools, that you don't need lots and lots of deep technical knowledge about APIs and the way they're built. There's a lot you can do with, again, common API testing tools: Postman, Bruno, Karate, Rest Assured, whatever. Um, and just a bit of a healthy dose of curiosity, creativity, and common sense. And I find that OWASP API Security Top 10 is a great guideline, heuristic, what you want to call it, to help you come up with ideas. As a resource, a final resource that I quickly wanted to share with you is APISec University. APISec University is a learning platform related to API security. Probably not a surprise here. So it contains a wide range of free courses all around API. So these are video courses, self-paced video courses. The quality of I've not even checked them all out, but I've completed a couple of them. More notably, I've completed these two, which are very much foundation level courses. I still need to find the time to do a couple more. But what I can tell you is that these are very, very high quality. They are well put together. They're good videos, good examples. And for everybody who wants to learn a little bit more about API security in general and API security testing, this is a highly recommended resource. Um, and that's it from my end. Before we go to the Q&A, I just wanted to very quickly say thank you so much for Paul, to Olga for having me, and for everybody who joined us or is watching this later, maybe, for taking the time out of your day to listen to me talk and demonstrate API security testing. All right, over to you, Paul.
Hey, that's well. I appreciate that. I gotta give a shout out to Olga because I was having some computer issues. She obviously took over. I did not catch the first few minutes of hear what was going on, but she is a fantastic producer on our side, taking care of when things just go slightly sideways. So shout out to Olga. Thank you very much on that. Um, I'm going to go. Let's take a look at. We only have a couple of questions, and I've got one I'm going to throw in there as well. We'll see. We are waiting for Alex to join us on here, so we may go a little bit beyond the break.
That is absolutely, it's fine. But I've got a couple more minutes, so that's
Cool.
absolutely fine.
Thank you very much. Anupam is asking, how can one prevent vulnerabilities while building an API in the first place?
It is a horrible word.
It is. I haven't had my coffee this morning, so I'll blame it. I'll put that on that.
Yeah,
vulnerabilities. My God.
Vulnerabilities.
Vulnerabilities.
Leaks, holes.
Holes. Yes. It was asked you to do standard.
That is if we had the answer to that question, Anupam, that would be the $1 million answer. The only thing is that it all starts with awareness. It starts A, with awareness, and B, with people who ask the right questions. And in that aspect, security is not really all that different from other properties of software. It is just what helps, I think, a lot, which is what we should do as more of what we should do more often in general as testers, is before we even start to build or even design something is okay, let's see how we can make this work, but then also talk about all the hundreds of thousands of ways in which it might potentially break down. So so prevent is a big word. Reduce the risk is definitely by having conversations about, well, how could this go wrong? What could people do to try? And then, of course, the follow-up question is, how are we going to test for that? How can we test? What tests are we going to perform? What tests can we do to see if we actually got a reasonably secure API? And again, it is the only API that's 100% secure is an API that's not connected to the internet.
Yeah.
And even then, there are ways, probably. But yeah, a lot of it starts with awareness and having those conversations about what can go wrong.
One of the things I was going to mention, had I been here on time, was that I have been working heavily in AI the last, 6 months. And one of the things I've found is that you go and ask an AI. You can also take some courses on how to ask AI prompts well. And there's actually one I'm looking at, probably nobody's heard of, so I always like to shout out about new stuff that I come across. There's a website out there called abacus.ai, and it seems to be fairly good at answering questions stuff. I actually have a litmus test that I do, is that I go and ask the AI about myself, because I know what exactly would be 100% correct information about myself, because I was there, I did it. And Abacus came back with 100% correct on not only a basic overall of Paul Grossman in test automation, came up with 100% in a detailed, where it took about 2 minutes searching the internet. So it was kind of interesting. I just heard about it because of my new job, and I was like, okay, this is impressive, because every other AI I've looked at, Gemini, I've looked at ChatGPT. It's their accuracy is okay, is 80-90%. You were going to say something, Bez. Go ahead.
No, it's just that I was just gonna confirm what you said. So they are reasonably accurate, and they are great at giving you suggestions on.
Oh,
Um, oh, this is a kind of an existential question that's coming in.
so
That's a good
so
one, Louisa.
yeah. So
So, but
Louisa,
yeah, about
go
this
ahead.
AI. So it's great for it. Let it help you generate ideas. Let it help
Yeah.
you um, come up with different ways to talk about and test security of APIs. Absolutely.
Okay, cool. So Alex is here, so I want to give one more shout out for you. If you want to know more about Buzz, his website is ontestautomation.com. According to the AI, you haven't written a book yet, so let's see if that's accurate. Is that true? There's no books by you, Buzz, yet?
No proper ones. I've written two short ebooks in the past, but the most recent one is 2020. So not really something worth mentioning. No,
Okay.
I it's maybe one of those things that I'll start doing when I grow up. I don't know. No, it is it's one of those that keeps on buzzing in the back of it. Oh, you should do that one day, and but I know from experience from talking to other people who've actually done it and from being a technical reviewer in some of those books that it takes a ridiculous amount of time.
It does. It does. I on mine, they said you got 6 months, and it took a year. And I kept, Douglas Adams is famous for saying, "I like deadlines. I like the sound they
Uh,
make
the-
as they go whizzing past my head."
and yes, no, it is maybe at some point in the future, but there's no concrete plans, nothing in the works.
Okay.
So no.
Well, I do know you that you've got training sessions and stuff. So I presume you can find out about that on your
Oh yeah,
on
it is
custom.
on my side, or just
Okay.
send a message, email. LinkedIn works. I spent way too much time there, so that's a great way to stay in touch.
All right. Fantastic. Any other final closing messages before we move on?
No, just again, good to see you. Thank you so much to you, to all the rest of the Testament team, and let's hand it over to Alex.
All right. Thanks, Buzz. Take care.
Yes, bye
Cheers.
bye.
Bye.